Welcome all of you for the subject power electronics. It is one of the very important subject as well as interesting subject in electrical engineering domain. At the end of this lectures, you will coming to know that one how the power electronics is influenced into the multiple number of the devices. Today topic we are going to see about introduction of power semiconductor devices. Introduction of power semiconductor device. This power electronics means what is there behind means that is called a power semiconductor device is there. So we're going to see about introduction of the power semiconductor device. Myself, I am Arul Murugan, professor in electrical department, Sanjeevani College of Engineering. We go ahead on the slide. This is a content we're going to see about this topic. What is power electronics? Application of the power electronics, classification of power semiconductor device, and a few review questions. First, we're going to see about power electronics. What is power electronics? Power plus electronics. Power, AC power, DC power, electrical power. We have general name is electrical power, AC power, DC power, electronics, power semiconductor devices, that is electronics. So it is used to, you will go to processing the electrical power. Processing the electrical power means you will go to conversion. You will go to conversion your requirement of your voltage and current. You will go to processing of electrical power to expected voltage and current. My expected voltage is a DC 12 volt. My expected voltage for my mobile phone battery 3.3 volt. 3.3 volt my expected voltage, and my ampere expected amps is a 2000 milliampere hours. So fast is charging, so lower charging, lower charge, it will take more time. So 500 milliampere hours, 2000 milliampere hours. So fast charging. So like about that one, your expectation voltage. So fast charging mobile device, you will go to adapter. Okay, that is called a rectifier or mobile phone charger. You will going to make. So 3.3 volt, 2000 milliampere hours. So like you will going to do the processing of the electrical power, that is a DC 3.3 volt I needed. So like you will going to achieve with the help of that power electronics. And what about that switching of that one power semiconductor on and off? It is a high frequency. So it is a kilohertz of that frequency. So we're going to see few of the applications. So industrial, commercial and residential purpose, this power semiconductor device is applicable. For example, electrical vehicle, there is a charge, what are the three major element? If you have see that electrical vehicle battery, another one is motor controller. That controller, it is doing for a combination of motor and converter and controllers, battery, even motor controllers. Another one is a motor. There are three major elements. So like it is electrical vehicle application, aerospace, and then space technology. Everywhere you have see the power electronics applications. So this slide show you general block diagram of the power electronics. Power electronics means it will going to reflected in the simplified small block diagram. This is a block diagram is represented. If I have see this block diagram, what is the purpose of the power electronics? Written the line control and conversion of electrical power. It will going to control as well as conversion. So there are two major role in the major role of the power electronics. One for that conversion of that one form of the power to another form, AC to DC or DC to DC. Why DC to DC? One fixed DC into that my expected DC. So DC to DC, AC to DC. If it is AC to DC means it's called as a rectifier. If it is a DC to DC means it is called a chopper. Another one is a DC to AC conversion. The third conversion is a DC to AC. It is called as an inverter. Then another one is a fourth one, AC to AC, that is called cycloconverter as well as voltage regulator. So this is a cycloconverter and AC voltage regulator, two converter. It will going to do for that AC to AC. What is converter? One form to another form. Which form to which form you are going to convert it? AC to DC or DC to DC or DC to AC or AC to AC. Like there are that this is a four type of the form. The form number one is a AC to DC. It is called as a rectifier. AC to DC. Mobile phone charger is doing rectifier. Small rectifier is there. So mobile phone charger. Then DC to DC conversions. Okay, chopper. Then, then third one, DC to AC. It is called as an inverter. UPS power supply. In your house, UPS is there means that is doing under the inversion operation. DC to AC. Then fourth one is AC to AC. It is do by that cycloconverter and voltage regulators. What is the difference between the cycloconverter and the voltage regulator? Voltage regulator means the frequency is constant. Fixed AC into the variable AC voltage. Okay, the frequency is a constant one, both input and output. Okay, but the cycloconverter fixed AC into variable AC voltage and AC frequency. That's all. This is a major for conversion is only behind about the power electronics. So you can see about the diagram, block diagram. This is a power electronic conversions. So one form of that conversion it will going to convert into your record form, AC to DC or DC to DC or DC to AC, like you will going to convert. Then load, from the load side you can sensor. Okay, sensor, current sensor, voltage sensor. Okay, or if you have motor load means you will going to speed, you will going to measure. Okay, proximity sensor, Hall effect sensor. For electrical vehicle, Hall effect sensor, position of that motor. Like the sensor it is used to, you will going to give the commands to the controller. The controller it will going to compare with the reference or my expectation. It will going to compare and then it will going to produce the pulse. It will going to produce the pulse. The based on the pulse, the concern switch of the power electronics conversion, it will going to on and off. That's all. On and off. The switch on and off with okay, it will going to give the command from controller. The switch on and off command is it will come from the controller. That's all. So this is a general block diagram. This is a block diagram is majorly it will going to tell every points. So we'll going to see about the few of the application of the power electronics. Then we'll go ahead on that power semiconductor devices. So is easy that one. SMBS, switched mode power supply. Where do you see the switched mode power supply? Every CPU, central processing unit, every computer it has the CPU. The CPU it has behind it is the one of that small box. The box is a SMBS. The SMBS it will going to give the power supply. What is that one? It will going to give plus or minus of the 5 voltage, plus or minus of the 12 voltage, and a plus or minus of the 60 voltage, plus or minus of the 30 voltage, like it will going to give the power supply. So this is application of the few of the application. Battery charger plays, low voltage and high current DC power supply plays, building machines with over 100 amps also you will going to design. So aerospace application, so like radar systems, so that one SMBS it will going to applicable. So CPU backside, that is a SMBS is a placing the vital role. The next one, see that one, it's a block diagram, it's represented. So input power, output power. The output power it will go to controller it will going to compare with that reference. So reference signals and then produce the gate signal. The gate signal or another name it is called a pulse. So you have to see about output, it will going to give the getting the information. Output is giving the information to the controller. So it is a act as a closed loop control system. It is act as the closed loop control system. The next one, high frequency conversion. Why you are go for that high frequency converter? When you will go for that high frequency conversion means, for example, the power electronics behind it is coming for that the advantages you can say high efficiency, low space occupations, high efficiency, life cycle is increased, so low space application. For example, you can see electrical fan regulator into electronics fan regulator. Electronic fan regulator, it's look like the small switch. Okay, small switch it is coming on that one with the point type, without point type. So like it is coming for the electronics. The space occupy is reduced. How it is reduced? So this type of conversion you will go for that high frequency conversions, automatically your size or space occupation is reduced. So this is application behind about that switch remote power supply. It will going to operate on that inverter, UPS power supply. So inverter DC into that AC powers. So what is the one AC voltage? You will going to fix as and mainly constant of the voltage. So for my electrical appliances, 222 to 30. You mean plus or minus of the tolerance, 230 voltage of the fixed voltage, 230 voltage of the fixed voltage. Variation current is vary with respect to the load normally. So fixed voltage. So like you will going to design your inverter. So application of the inverter, power, AC power supplies, and then AC drives. So drive controller. So you will going to drive controller systems. Okay, another one is induction heating, electronics, ballast. So like it is that will going to applicable. So further you have see that one, even medical appliances, medical appliances is there, electromagnetic interference control systems. So what is the shaping of input and output and the voltage and the current you will going to decide. Switch mode amplifiers, amplifying the harmonics waveform generating systems. So harmonic waveform generating systems, and then power factor corrections, particularly in power electronics device use and the transmission line. The transmission line, this particularly semiconductor device. Which semiconductor device means which one is very higher rating caliber semiconductor device, higher power rating SCR is using for the power factor correction. It is applicable. Active filters, so reduce the harmonics, like it is the applications. So uninterrupted power supply. Okay, variable speed drive. So I want to control my drive speed, so you can use for that one's variable speed drive application. Okay, power electronics components. When you have see that one inductor, capacitor, transformers, these are the energy storage components. When you have see the power semiconductor switches, so these are the switches is active switching devices, MOSFET, IGBT, thyristor, gate turn of thyristors, BJT, bipolar junction transistor, diodes. Okay, so and then classification of the diodes, like this is classified the power semiconductor devices. So first you should be know what is the advantages and disadvantages as well as application. Now application is completed. Advantages means what is the advantage? It is occupy very less space, high efficiency, the durable, I mean life cycle is a good about life cycle, maintenance is very less. Okay, like it is about that one, and cost wise also it is a less. Okay, and it does not produce any heat. So these are the advantages, and a few of the disadvantages also there. So it will come to harmonic generation due to that power semiconductor devices and then elements. Okay, it will going to generate harmonics. Okay, low overload capacity. Another one is a low input power factors for that conversion operations, like few of the drawback also there. So for so many applications the power electronics device is applicable. Okay, so let's we going to see about that. Next topic is a power semiconductor devices. So power semiconductor devices means, so you can start with a diode. Another one is a control devices. So generally it will going to classify into two. Okay, uncontrolled devices, controlled devices. What is uncontrolled devices? So no gate terminal, it will going to turn on and turn off automatically. So turn on means when you have power is come, it will going to turn on. For example, simple to say door. Okay, it's a flexible door. So when it is a more wind, the door is open. Okay, in one directions. Okay, when it is a okay, no wind means, so you will going to automatically it is a close. So like backside it is there for that some devices used to automatically close. Like what happened, this is a one-way directions, the door it is a one-way directions, like that a diode it is going to operate a diode. Another one is a controlling devices. Controlling devices. What is a controlling device? You can say SCR. Okay, current control device, voltage control device. Then it will going to classify current control device, voltage control devices. Okay, what is the current control devices? SCR and BJT, bipolar junction transistor. You can say what about voltage control device? You can say about MOSFET devices, MOSFET and IGBT. Like it is a voltage control devices. So like it is based on the control wise, it will going to classify. Further, you can go deep about that one. Let's we go further one deep about that power semiconductor devices. See the slides. The slide it will going to say it will going to show about that the semiconductor device thyristors. If have see thyristor or another name is called SCR, silicon controlled rectifiers. Okay, another one is a devices it is showing about that one is okay controlled on control off devices it will going to classify. So BJT, MOSFET, GTO and IGBT controlled on control off characteristics. So this is about the power semiconductor devices. Okay, so further detailed about the power semiconductor device, we're going to see about in another video. So we're going to come to that end of the video. Okay, so definition of the power electronics. What is a power electronics? Power plus electronics. Okay, control and conversion of that operation with the help of the power semiconductor devices. So list of the power semiconductor device. So what are the list you have seen about the power semiconductor device? Diode, SCR, BJT, MOSFET, FET, IGBT, like you can say about that one. What are the current control device and the voltage control device? What are the current control device? SCR and BJT current control device. Next one. Okay, what is voltage control device? MOSFET, IGBT, FET devices. So comparison between SCR and GTO. GTO is come under that thyristor family. Come under the thyristor family. Thyristor another name is called SCR, silicon control rectifier. So next slide, next video, we'll going to detail this. We'll going to see about that word deep about that what is the GTO and SCR. And even I will going to touch about the lines about the when you have see the comparison. So SCR is a controlled on, uncontrolled off. Controlled on, uncontrolled off. GTO is a controlled on, controlled off. That's all. Controlled on, controlled off. So next we will going to slide. You will going to see about that one. You have seen about the symbols. Further we will going to detail. We will going to see about SCR, diac, triac, GTO, IGBT, and a MOSFET. Thank you.